Good afternoon, everyone. Thanks for attending today's webinar on refrigerants. This webinar is posted to the Code Adoption Toolkit, usually within a couple of weeks. If there are any issues with audio, feel free to write me in the chat. My name's Erica DeLallo. I'm a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by Group 14. So we've been working with the Colorado Energy Office to push out a bunch of different types of trainings that are available to you guys. So it's this webinar series. We've got a few more throughout the month of June, and then we're hoping to also continue to add some throughout the end of the year. So keep an eye out for updates on that. And then we do have a training series that's called role-based trainings. And essentially what it is creating a more in-depth training through the eyes of the code user. So for example, if you're an architect or a designer or an engineer or contractor, HERS rater even, or you work for the building department, we have a series of trainings that are specific to your role when complying with the energy code. And they go through real project examples, what to look for as it relates to the energy code and all that good stuff. So if you are interested in requesting a role-based training or just a regular group training, feel free to reach out to me and we can get you guys set up. Now, we also provide technical assistance for code adoption throughout the state to get jurisdictions up to the 2021 codes. So if you are a jurisdiction that's looking at updating their codes, then feel free to reach out to me on that as well. And then we've got a bunch of different resources that are available on the Code Adoption Toolkit. It's being updated all the time, but essentially you can look through that for all of our previous recordings of these trainings as for reference. And then we've also got the Colorado Codes helpline that I want to highlight today. This has been a resource that we've had for the past year or two. It's really starting to gain some traction here, but you can submit a question on any of the I codes and a subject matter gets back to you in just a few business days. So utilize this as a tool to help you guys comply with some of the different requirements within each jurisdiction. If you have questions on how to comply or how to inspect or what that looks like, we're here to help. Okay, so throughout the webinar, we do want to encourage questions. So please use that Q&A function and I'll let our presenter know at the end of the presentation. There's also that ability to raise your hand and ask a question at the end and I can unmute you. And then lastly, there's a survey window that'll pop up following the webinar. So if you could please take a moment to fill out that survey, it helps us to continue to improve on these webinars and then also create training topics that you guys are interested for the future. So today's presenter is Anna McCullough, and she's a professional engineer with over 12 years of experience in HVAC design and building performance, energy performance. She's designed commercial and multifamily HVAC systems. She's an expert in building analysis and utilizing different programs. Anna's got design and energy modeling experience that spans a wide range of building types, including airports, offices, schools, multifamily buildings, recreational centers, and government buildings. So with that, I'll go ahead and pass it over to you, Anna.
All right.
So that you can share your screen.
Sounds good. Everybody good?
Looks good.
Nice. Okay, so hi everyone. For those of you who I don't know, my name is Anna McCullough. Like Erica said, I'm from Group 14 Engineering. And today we are talking about refrigerants and the upcoming changes. We're going to talk about how this will impact system design. We will talk about what the requirements are. And then lastly, we'll talk a little bit about energy efficiency as well. Again, if you have any questions as we go through, this is a very high level overview of what the requirements are, why they are important, and how it will impact all of you. If you have any questions, feel free to type them in the chat or the questions and answers box, or raise your hand, and I'm happy to be interrupted. Just let me know. So First, we're going to just talk about what is a refrigerant. A refrigerant is the working fluid that DX systems and VRF systems, chillers use to reject heat or pull heat from the environment. So we see that you guys are all familiar with the refrigeration cycle. We have a condenser and an evaporator. The same thing goes for a chiller. This refrigeration cycle happens within your chiller, whether that's an air-cooled chiller or a water-cooled chiller. If you have a rooftop unit, this refrigeration, and you have DX, this refrigeration cycle is happening. So we all know that refrigerants contribute to global warming. The Montreal Protocol was signed back in the 80s. And what that protocol required was that governments reduce the global warming potential of the refrigerants that are in use. In 2020, the AIM Act was enacted into law. And this act requires the EPA to reduce the production of HFCs in the US. HFC stands for hydrofluorocarbons, and I will only say that word once while I'm being recorded. But the requirement here is that the refrigerants that are currently in use have a higher global warming potential than what is currently allowed by the AIM Act. So the goal is to shift the industry to refrigerants with lower global warming potential. And as a part of that, this will reduce the production of these HFCs as we shift the industry. So, what are the new requirements? In this first slide, we're looking at, we're going to go through the requirements for a few different types of equipment, not all of them, but just kind of the major ones. We will see this is directly pulled from the EPA's website. So you'll see subsector, the type of system, the limit for the global warming potential of the refrigerant, and then the installation compliance date. I do want to say that we are going to talk a little bit more about what the global warming potential limits are for different types of refrigerants, so you have a little bit more background before we get into some of the requirements. So first, we have stationary residential and light commercial air conditioning and heat pumps. So these are your split systems, your unitary rooftop units, your air handling units with a split DX. All of those systems are going to have can only use refrigerants with a maximum global warming potential limit of 700. And they must be installed by January 1st, 2025, asterisk. They can be installed until January 1st, 2026, if they are manufactured or imported before January 1st, 2025. So a good note here, in terms of drawings and design, we're not going to see some of these requirements hit the design community probably until closer to the end of the year here. We should be starting to see design teams consider these requirements and how they will impact the design. But for any systems that have been manufactured or imported before January 1st, 2025, they can still use the R410A refrigerant coils that are in production and in use now. For stationary air conditioning and heat pumps that are variable refrigerant flow systems, so these are the VRF systems that we commonly see in offices and multifamily buildings, the same global warming potential limit is there, but this installation compliance date is January 1st, 2026. If we look at some larger pieces of equipment like chillers for industrial processes, those requirements go into effect in January 1, 2026 for the not as cold chillers. And then the really cold chillers or the medium cold chillers, that installation compliance date is January 1st, 2028. And then the really, really cold ones are not covered. They do not have a good solution for that replacement refrigeration under those required cold temperatures. And then if we look at the chillers that we are going to most likely see that are used for comfort cooling. So for example, if you have a office building with a air cooled chiller on the roof, or a school with an air cooled chiller on the roof, that system will have to be the lower GWP potential refrigerant as of January 1st, 2025. Data centers, computer room air conditioning, and information technology equipment cooling. These are CRAC units. So if you have a large data center and you have a piece of equipment that's just serving the data center, those types of equipment do not need to be, do not fall under this requirement until January 1st, 2027. Then lastly, we're going to talk about retail food refrigeration systems. This is based on the amount of refrigerant charge within the refrigeration system. Solely looking at supermarkets here, the global warming potential limits are different, but they do not come into effect until January 1st, 2027. Okay, so HFCs have a high global warming potential, as you'll see here. Their global warming potential is hundreds to thousands of times higher than a CO2 refrigerant. And so these new refrigerants are being created, HFOs and blends, which is an R454B. So most manufacturers are shifting to R454B. It is combined with R32. So it is a blend of an HFO and an HFC, which lowers the GWP rating. So you'll see here we have kind of this R120. I don't know the shorthand for saying this one yet, but R1234ZE has a GWP rating of 7, which is great. But it is an HFO and it comes with some additional requirements just based on what's called the LFL. And we'll talk a little bit about what that is. But so to overcome the additional restrictions around R1234ZE, manufacturers are blending it with R32. R32 has a higher GWP rating. So if you'll remember, that maximum allowable GWP was 700. And R32 has a GWP rating of 675. And so some manufacturers feel a little bit concerned that the maximum GWP rating will be dropped again soon, and they will no longer be able to use the R32. So they are blending R32 with R1234ZE to create R454B. It has a lower GWP rating of 466, so well below the current or the upcoming requirement. But they are all three of these refrigerants are classified as an ATL, A2L. So what is an A2L? If you'll remember, in this chart, R410A and R134A, which are the refrigerants we see most commonly in new construction right now, these are all listed as their safety classification is listed as A1. So when we look at this chart, we see that A1s have no flame propagation and they have a lower toxicity. We are bumping into this A2L range, which still has they're classified as mildly flammable, but they are still a lower toxicity. Uh, the trouble here is that now that they are mildly flammable, if the concentration within the room meets a certain amount, so it's called the lower flammability level, LFL, and there is an open flame in the room, there is a higher risk for that refrigeration to ignite. So with all of that, we are going to have additional requirements, life safety requirements that will impact construction and design. So what is an A2L? Let's talk a little bit more about that. A2Ls have been used overseas and in residential and commercial HVAC equipment for some time. They are most commonly used in small HVAC appliances such as window units and packaged terminal air conditioners. And they are being manufactured now. These coils just have a very small refrigerant charge. And so they do not meet any of the requirements that we are seeing come into play now and kind of affect the design community. So a little bit more information about how this will affect code review and what the requirements are. In the 2021 IMC, they do not have an A2L classification. Right now, the A2Ls are A2 refrigerants are listed in the 2021 IECC. And then the 2024 IMC is being updated to include calculations for the life safety measures around A2L refrigerants. ASHRAE standards 15 and 34, they're a package deal, and you can find them for free on the internet if you need some light reading before bed. Do classify A2L refrigerants differently than A2. And the calculations that the designers will use for the maximum, well, we'll get into it a little bit more, but some of the factors within these calculations that are in ASHRAE and the IMC differ slightly. The 2024 IMC is very close to what is included in ASHRAE, but there are some kind of minutia that make the 2024 IMC slightly harder to comply with than the ASHRAE standards. We are not going to get into that level of detail of minutia, but it is important as we are reviewing or completing these calculations that we make sure we are referencing the correct code and the correct year. Okay, so the requirements for the refrigeration or the life safety systems change based on the type of HVAC system that you have. So if you have what is called a high probability direct system for human comfort system, you are going to require additional, there will be additional requirements to make sure that you do not have potential for that A2L refrigerant to leak out and light on fire. So we have two examples here. We have a split system where the coil is directly in the space. And then we have the example of a packaged rooftop unit. This is a ducted system. And so if, for example, this coil with all the refrigerant in it leaks, we would have the potential for that refrigerant to be supplied through the ductwork into the space where all these people are. There are additional classifications based on where the system is located. So if your system is completely located within your space, think about a water source heat pump. You have it located in a closet in a residential unit. That water source heat pump has refrigerant in the system. And so that system would be this class 1, the mechanical equipment is within the occupied space. If you have a split air conditioning unit or a heat pump where you have the condensing unit outside and the evaporator inside, you have a class 2 system. If you have a system that is completely outside, think about a air-cooled chiller. That's going to be a class 3 system. And then if you have a ventilated enclosure, I do not have a good example for one of those, but they are a special design that I have not done. These systems, where this unit is located, is going to impact the type of life safety requirements that are mandatory per ASHRAE or the IMC. So, based on the type of refrigeration, the type of refrigerant, there are maximum charge sizes allowed. This calculation is based off of the type of refrigerant. And on average, we estimate that the charge size of an A2L refrigerant is only 18 point, allowable charge size of an A2L refrigerant is only 18.5% the charge size of an A1. So that R410A, now we can only have 18.5% of that refrigerant in an A2L system unless we provide additional life safety measures. So some of these requirements are going to be mandatory, whether not based on charge. And one of these is, for example, a split system or a VRF system, where you have refrigerant lines that are installed in concealed locations. They're not on like the inside of the wall. In our office, we have refrigerant lines that are just like on the inside of the wall and you can just see them. If you have refrigerant lines that are concealed within studs, joists, rafters, or similar, they're required to be protected by steel shield plates. What we don't want to have happen is somebody is going to hang a picture on a wall and they have no idea refrigerant lines are in that wall. They puncture the line and now we have an A2L leak. If these refrigerant lines are in pipe shafts, in refrigerant pipe shafts, they are required to be naturally or mechanically ventilated. So there are different requirements for the natural ventilation or the mechanical ventilation. And this is just a quick summary, and I'm making a very complicated issue seem not complicated. Naturally ventilated shafts must have a minimum diameter 4-inch pipe that slopes downwards from the bottom of the shaft to the outdoors. So the idea is our refrigerant is heavy, right? You have Joe over here hung a picture on the wall, pierced that right into that pipe shaft, pierced that refrigerant line, and now we have a leak. And that refrigerant is going to fall to the bottom of the shaft, find its way to this 4-inch diameter pipe and out. You can also, if you do not have the capability to provide that 4-inch pipe to the outdoors, you have the option to provide a mechanically ventilated shaft. And they must be operated, that mechanical ventilation must be operated continuously or controlled by a refrigeration detector. So here's an example of a what's classified as a machine room refrigeration detection system. So we have 3 chillers in a mechanical room. Those chillers are have more refrigerant charge than is allowed without a refrigerant detection system. We're going to include the refrigerant monitor, which will sense if there's a certain amount of refrigeration. I'm going to keep doing that. A certain amount of refrigerant in the space. It will activate a fan to provide ventilation. And then we will have a visual alarm and an audible alarm. Refrigerant detectors will be required when the system charge is greater than 0.212 LFL. LFL is the lower flammability limit. These limits are assigned to different types of refrigerant within ASHRAE and within the IMC. And I believe the LFLs are identical between ASHRAE and the IMC. So, for example, if you have an R32 refrigerant and your system has a charge of greater than 4 pounds, you are going to be required to have a refrigerant detector system. When the detector senses concentration of 25%, the lower flammability limit, so this is the pounds of refrigerant that can escape. So 25% of that lower flammability limit, the supply fan airflow rate is going to kick on to meet the minimum requirement, and that requirement is based on the volume of the space. If you are a ducted system, so you're a rooftop unit in an office, you are going to be required to include that detector actually within the space, not within the ductwork or outside next to the unit. That detector is located in your space. There are also additional mitigation systems that can be included to reduce the potential for life safety issue. So particularly, and this is where we start talking about the particular issues with VRF systems. So safety shutoff valves are going to be required to isolate refrigerant piping and reduce leak capacity. So if you think about a VRF system, we essentially have a ton of refrigerant that is being circulated around your building to recover heat, to reject heat, to absorb heat. We are using all of this refrigerant to transfer heat from one space to another, and it can be a very efficient system. But that heat recovery is all happening through the refrigerant that is being cycled around the building. You then have these main lines that come back to your outdoor condensing unit. If I can find my mouse, there it is. So when we think about the total amount of refrigerant that is included in a VRF system, it's a very large charge. It's going to be greater than the limits. Oftentimes, it will be greater than the limits that are set on these new A2L refrigerants. So we will now provide these, or the industry will now be providing these shut-off safety valves. So essentially what will happen is that if there is a refrigerant leak within the system, the valves will close and it will minimize the amount of refrigerant that can leak out of the location where the leak, out of the spot where the leak is located. This basically minimizes the potential for reaching that maximum LFL, and that we talked about in the last slide, and can just really reduce the potential life safety impact of a refrigerant leak in a VRF system. These lines will still all have to be enclosed within that steel gauge casing that we talked about. And we'll also be required to have detection and then the ventilation system as well. So if we we have the detection, the safety valves close, and if that system meets the maximum LFL that we talked about in the last slide, the ventilation fans will turn on. We also have energy code impacts here. So, something that's really interesting about A2L refrigerants is that they have a higher heat rejection capacity at higher outdoor air temperatures, meaning that equipment that utilize A2L refrigerants are more efficient at rejecting heat to the outdoors when it's hot out. And this increases the energy efficiency of the system. So we expect to see a 10 to 30% reduction in cooling energy use. Um, and that will impact the energy code moving forward, where we will see updates to the minimum allowable energy efficiency ratios or COPs listed in the energy code to better reflect what's available in the market. Um, we also will see that these systems that are more efficient, we can now use them to trade off within the efficiency calculations for Section C407 energy modeling, just using a more efficient equipment. They are approximately equivalent at heating efficiency, but it's the cooling efficiency where we really see these A2L refrigerants shine. Don't be fooled. This 30% reduction here, we're talking about the reduction in GWP potential from R410A and R22. So that is, I was expecting quite a few questions. Do you guys have any questions? We can unmute people, type them into the chat, but that is what I had for you guys.
Thanks, Anna. Okay, it does look like we have one question that came in through the Q&A. So that first question is, what about refrigerants for walk-in coolers and freezers for non-supermarket installations, for example, restaurants?
Yeah, so there's a good, Denise, I can send it to you where this is located on the EPA's website, but they have a really good chart that requires the refrigerant maximum GWP and installation date for those non-supermarket installations. And I believe they're all 2027, but I'm going to triple check for you. And then those GWP limits are going to be the same as these, this 300 with the less than 200-pound refrigerant charge. But I'll send that to you.
Okay, thank you. Okay, we've got a few more questions coming in. All right, next one is from Lindsay. Will steel protection be required for lay-in grid or other accessible ceilings?
It's a good question. I do not believe it's required within the lay-in grid, as long as the lines are visible and they are not visible when you move the tiles, unless you see a let me get back to you on that, but I don't believe they're required. I just want to triple check.
Sounds good. Okay, next question. Any insights into the future of A3 refrigerants being allowed on monoblock type equipment setups?
Yeah, that's a really good question. And it's one that I have as well. So, you know, as you guys see here, the A3 refrigerants have a higher flammability rating. There's still that lower toxicity. They're the A classifications. And we do see a shift towards those, particularly within those equipments, the monoblock equipment setups. I don't know where the industry is headed on that one and when it will be allowed, but I agree. I wish I had more of an answer for this one. You guys have good questions, but I wish I had more of an answer for this one. We don't know of a solution quite yet.
All good, Anna. It's always it's always fine to say that you can get back to them later, or
Yeah,
whatever
the
it is. Some of
industry,
these are tricky questions, right? This
the
is
industry just doesn't have a solution quite yet.
yeah, yeah, exactly. Okay, I've got a question in the chat. Can you provide us code references for all of this? Is it for residential or commercial? I believe this is for commercial, correct? Yeah.
Small residential equipment will also be impacted by these requirements. So you'll see stationary residential and light commercial air conditioning and heat pumps are listed here. So the residential requirements, residential systems will be required to meet, to use A2L refrigerants starting in January 1, 2025. And they will have to meet that maximum allowable refrigerant charge requirement or be provided with the detection systems.
Perfect, thank you. When do you know to use the protective shield versus a rated shaft?
So the a lot of that's going to be based on the fire safety code that you have in place. If you have Frank, I can get you the whole list of requirements here. I don't have them right in front of me. But the fire protected shaft, if you have that fire protected shaft, even if you are a 2 hour rated shaft, you are still going to have to provide this protective shield. I can't remember what the rating is that you can go up to where you don't have to provide the shield, but if you can puncture through that wall and get to the refrigerant lines, you have to provide the shield.
Sorry, I hit everything on my screen. I was having trouble unmuting. Okay, that sounds good. And then I've got one more question in the chat, or more just request for comment on heat pumps. You said it was best for when it's hot outside.
Yeah. So these refrigerants have a great capacity for heat rejection when it's really hot outside. They are approximately equivalent to the efficiency of A1 refrigerants when it's cold outside, so in a heat pump scenario. But you will see for chillers that are rated for industrial processes with the exiting fluid below negative 50. So sorry, below negative 50, that they're not covered within this requirement. And that's because you're using a specialized refrigerant that can meet these temperature requirements, which A2L refrigerants cannot. So obviously a heat pump doesn't require an exiting fluid below negative 50, but we will see similar performance between an A1 and an A2L refrigerant for heating.
Thank you. I've got a raised hand from Derek. I'm going to go ahead and allow you to talk, Derek. So you just need to go ahead and unmute yourself and you can ask the question directly.
Hello, Anna. So when we leave these rated shafts and our provided protection, and let's say we jump into a plenum interstitial space, and it's not ducted return, it's actually a plenum return. Do we need to continue to protect and provide protection for those refrigeration lines? Because that hazard will now exist in the breathable portion, whether it's a heat pump or a fan coil unit or some heating cooling apparatus. It's now in that breathable zone.
Mm-hmm. Yeah.
What's our concerns there?
Yeah, absolutely. So there are a couple different considerations on once you leave your protected shaft. So the first is if you have a safety shutoff valve when you leave the shaft. So I think about chilled water, heating hot water when you have just safety shutoff valves at every riser, right? You are reducing the amount of refrigerant that can be leaked from the shaft into that return plenum, or you are reducing the amount of from both sides of that safety shutoff valve. Sorry. So then if you have that safety shutoff valve, the calculation can be completed to determine if the charge within that refrigerant line set and evaporator that you have in the space within the plenum is is greater than the allowable LFL. If it is, then you have to provide the detection and ventilation.
Yeah, detection. That was my question too. That was going to be my next question. So detection in plenums then also, much like duct detectors that we have now for smoke.
Yeah, absolutely.
Okay. Thank you.
Sure.
Thanks, Derek. Okay, back to the Q&A. We've got Seuss. Are there any rules of thumb for refrigerants and for refrigerant types and project size / type, offices, multifamily, for example, based on BTU capacity size of systems to optimize per project type in order to reduce these additional costs of monitoring?
Yeah, so some of that's available. You will see kind of this, and I can pull up the chart for you guys. So when we have a refrigerant charge greater than this 0.212 times the LFL, and those LFLs are available in the IMC, you'll see that that's when the detection is needed. For a system with R32, which has a slightly lower LFL than R454B, you are going to only have an allowable system charge of 4 pounds, which is very small. And so you'll be required to have that detection. So essentially, what we're going to be seeing is that most systems, if you have refrigerant that is within your building, so you have a split system or you have an RTU, you are going to probably require these detection systems. A 4 pound refrigerant charge is fairly small. And then for the R454B equipment, the refrigerant allowable refrigerant charge is smaller. So I wish I had rules of thumb that said you could provide this system and you won't have any issues. You won't have to provide detection. But I believe most systems and most building types will require detection unless you put an air-cooled chiller outside your building or use direct evaporative cooling.
Great, thanks, Anna. Got a few more questions for you. You're right to anticipate lots of questions on this one. We are hearing from contractors that the added costs here end up in the range of $20K per shaft. What do you all suggest to help mitigate that while still early in the design? Any architectural strategies?
So we're really struggling with this as well and coming up with creative solutions. If we can provide that natural ventilation solution where we have the 4-inch pipe to the outdoors, that's going to be a very cost-effective solution rather than providing the mechanical ventilation. You're still providing the detection system as well as the refrigerant safety protection around the shaft. And then we also actually recently, shockingly, had an architect suggest putting the refrigerant on the outside lines on the outside of the building and protecting them on a shaft that is actually located outside of the building. So rather than taking the shaft within the thermal envelope of the building, we're including it on the outside of the building with a protective metal encasing around the outside. It's like a little block coming up the outside of the building. And that is what we've come up with so far. I wish I had more solutions.
Thank you. All right, next one. Will the protective shield be required in residential?
I believe so, Jim. I got to get back to you though.
Sounds good. All right, for condensing unit replacement of an existing system, existing lines could not be used. They're within concealed walls.
So this is tough, David. So systems are designed for the refrigerant that they are let me start over. Systems are required to use the refrigerant that they are designed for. You cannot replace an A1 refrigerant with an A2L and maintain the same equipment. Those refrigerant lines, A2L equipment, A2L equipment will also require different amounts of refrigerant charge than A1 equipment will. And because of that, your line set sizes may actually change based on the type of system that you're talking about and the difference in the change in refrigerant. If you are using, you're replacing your evaporator and your condenser and just trying, and you can still use those same line sets, I believe they will be required to be protected. As long as they are encased and enclosed and you cannot see them, you cannot run the risk of puncturing them and lighting a fire.
Okay, just a couple more for you. Will the installing contractor, EOR, or the equipment manufacturer be responsible for the additional safety measures, i.e. shutoff valves, ventilation, function as required?
I think, Danny, if I'm understanding your question correctly, the engineer of record is going to be responsible for providing the calculations to determine if the life safety requirements are required. If they, what life safety requirements are required. And then if there are additional life safety like detection and ventilation, the engineer of record is going to be required to design those systems to make sure that they are compliant with the IMC and ASHRAE. Did that answer your question?
I think it did. And I mean, after that point of if it's included in the plan set and it's not installed properly, or, that's where the transfer of responsibility kind of happens. So
I believe so, but I don't want to speak for any contractors. Have somebody bang down my door.
Yeah. All right. A couple more questions. Let's see. Equipment has to be designed for a specific refrigerant, right? Which I think you kind of spoke to a little bit earlier, but that answer is correct. What happens when servicing equipment in the future that have the older refrigerants?
So, those systems are allowed to be serviced with the refrigerants that they have, as long as their manufacturer has that, or service technician has that refrigerant available. Manufacturers are not allowed to stockpile the HFCs like in previous versions of refrigerant changes. So those refrigerants will be retired relatively quickly. Once that equipment is replaced, I think I kind of spoke to this earlier, but once that equipment is replaced, you cannot charge a system that was designed for A1 with an A2L. It will not work and you'll run into a whole lot of trouble.
Makes sense. Okay, last question that we have right now, and then Anna and I will stay on the line for just a couple more minutes if any other questions trickle in. But this one is, will the commissioning report or plate list the refrigerant being used?
They should. The plate, even on existing equipment now, lists the refrigerant that's being used. The design should list the refrigerant that's being used because these calculations change on the allowable charge based on the type of refrigerant. So you want to see it on the design. The equipment will list it. And then typically, at least our commissioning reports, I know we list the type of refrigerant. I don't think that is a listed specific requirement within section C408, but typically it is provided.
Great. Okay, that's all the questions that I have on the docket for today. But as I said before, Anna and I will stay on the line if any others come in. But thank you, Anna, for your presentation today, and thanks for everyone for attending. Please expect those continuing education credits to be sent out likely next week. I try to do it at the end of each month to capture all of the trainings that we've done within each month. So keep an eye out for that. And yes, Jim, you can get a recording of this. It's posted to the Code Adoption Toolkit on the Colorado Energy Office's website. So if you just kind of Google Code Adoption Toolkit for Colorado Energy Office, it should be one of the first websites that pop up there. Okay, I'm going to go ahead and stop the recording.